A narrow emerald cone leaks from the pulsar like a laser that forgot it was born from a star's corpse, its beam a pencil of polarized synchrotron light sweeping the dark with millisecond regularity, clockwork carved by a neutron sphere only 20 kilometers wide yet heavier than a sundae. In the magnetosphere, electrons and positrons are torn from the crust and whipped to near light speed, cascading through curvature radiation, pair production, and cyclotron resonances. Their chorus imprints a dispersion measure that tells you how much thinly spread plasma lies between here and there, while subtle Faraday twists sketch the magnetic script of the interstellar medium. Every rotation drags the light cylinder around like a centrifuge for fields, and near that boundary the striped wind, the alternating magnetic polarity of a dead star's heartbeat, rolls outward to meet the cosmos, building a bow shock where it rams the gas ahead and seeding a nebula of high-energy photons that paints the vacuum in faint, greenish chemistry. Just inside that fan of radiation drifts a crescent world, its night side wrapped in quiet chemiluminescent threads as oxygen and hydroxyl glow in thin airglow layers, the high atmosphere whispering in 557.7 nm and 630 nanometers lines while the terminator glints like a blade. The ionosphere answers each sweep of the beacon with transient ripples in electron density. Lyman alpha from space knocks electrons loose, auroral arcs wink at the poles where trapped particles precipitate, and the photochemistry cycles like a tide. O2 splits, O recombines, OH vibrates and relaxes, and a faint red limb betrays the altitude where metastable oxygen finally gives up its stored energy. Trace molecules, CO, NO, perhaps even CN lofted from dusty exospheres of micro-impacts, leave spectral fingerprints that drift with upper wind shears, a palimpsest of winds and light written on a shell thinner than a spider's thread compared to the planet below. Beyond this intimate theater floats the Medusa of the night, a jellyfish galaxy half-stripped and still beautiful, its starlit disk plunging through a cluster's hot intercluster medium at 1,000 kilometers per second. Ram pressure does the tearing. Like a cosmic headwind it pushes on gas but not on stars, peeling cold clouds from the disk and combing them into tendrils that trail for tens of kiloparsecs. In those tails, shock fronts and Kelvin, Helmholtz billows shred and reassemble molecular reservoirs, magnetic draping wraps the flow and sometimes stabilizes filaments long enough for gravity to pinch clumps into newborn star clusters. H-alpha stitches, UV knots, and soft X-ray veils interleave along each streamer, a panchromatic testimony that star formation can flourish even in exile, far from the mother disk. The tentacled wanderer carries gradients in metallicity down its arms, iron and oxygen diluted by mixing with pristine cluster gas, while CO and C2 mark the surviving pockets of cold, dense phases amid a bath at tens of millions of Kelvin. At the galaxy's core, a ravenous nucleus may flicker on. As the stripped gas is funneled inward by torques and turbulence, the black hole drinks, and feedback explodes outward, entraining dust and carving cavities that echo in O3 and radio continuum. Sometimes the nucleus is quiet and the quenching is slow, strangulation, as the halo's supply is choked off. Sometimes it is sudden, the disk shocked into silence while the tails remain luminous, a paradox of death at the head and birth in the wake. Look long enough and you can read the timing of this whole scene. The pulsar's period derivative tells you its age and spin-down power. Glitches, tiny jumps in rotation, announce starquakes within a crust denser than atomic nuclei. The planet's airglow brightness follows solar cycles and stellar weather, a barometer for high-altitude chemistry. The Medusan exile wears time in the length of its gaseous hair, in the offset between stripped gas and lagging stars, in the entropy rise of the cluster air that embraces it. Map the polarization of the pulsar beam and the tail's radio filaments and you connect field lines across scales of 20 kilometers to 200,000 light-years, a single, continuous circuitry of the universe where pulse and chemistry, gravity and wind, all conspire to turn darkness into structure and silence into measurable light. Radio telescopes lock onto the beacon and harvest its timing like a metronome for space. Minute fluctuations in arrival times chart the plasma weather along the sightline. Dispersion measure swells when a density ripple passes, shrinks as the path clears, and the residuals carry hints of microstructure, Kolmogorov turbulence in the ionized medium, tiny lenses of overpressured gas focusing and defocusing the pulses. The braking index betrays how the spin energy drains into a particle wind. A value below the dipole ideal tells you that outflows and evolving magnetic geometry share the bill. X-rays reveal the wind nebula as a cometary blur, its standoff distance set by the ram pressure balance between the pulsar wind and the ambient flow. In hard photons, the termination shock glows where bulk motion turns to random heat, and the electron spectrum steepens downstream as synchrotron losses bite. In TeV gamma rays, inverse Compton scattering on starlight and the cosmic microwave background completes the ledger, closing the energy budget of a city-sized dynamo. The crescent world answers in chemistry. Meteor ablation leaks sodium and potassium into the exosphere, a faint, lemony ring that waxes after meteor showers and fades with photoionization. On the limb, the familiar green oxygen line cohabits with a red doublet, while OH nightglow bands ladder down from vibrationally excited states born in the recombination of H and O fragments. Ion molecule chains in the mesosphere stitch together NO and CO2, and polar cap arcs shimmer when reconnection opens the magnetosphere and hands solar wind energy straight to the upper atmosphere. Gravity waves, launched by storms far below, steepen and break in the thin air like surf on rock, modulating the airglow into ripples you can literally photograph from orbit. Even the Terminator is a laboratory. Rapid heating there drives a supersonic day-to-night flow, and the ionospheric F-layer puffs and sinks to the rhythm of stellar EUV, carving daily tides into the electron density that a passing pulsar beam can diagnose with exquisite precision. Farther out, the tentacled disk plunges on. Ram pressure stripping writes clean equations into a messy sky. When ρ_ICMV superscript 2 exceeds the galaxy's restoring force per unit area, gas detaches and streams away, leaving behind a stellar disk that looks oddly undisturbed. Yet within the tails, order emerges. Magnetic draping aligns field lines along the galaxy's nose, reducing cross-field diffusion and helping cold clouds resist thermal evaporation by the million-degree intracluster plasma. Shear layers at the cloud-wind interface host a factory of turbulence. Eddies cascade from kiloparsec billows to parsec-scale knots where shocks compress gas to densities high enough for molecules to reform, with dust grains surviving by hiding inside the densest clumps. H-alpha filaments trace ionized skins, O2, and O3, highlight shock and photoionization zones, far UV sprinkles out the teenage stars, and millimeter lines from CO and HCN betray pockets of molecular survival that would have seemed impossible in such a hostile bath. Star formation in exile has its own rules. Without the ordered spiral density waves of a serene disk, gravity leans on turbulence and shocks to gather material. The star formation efficiency per free-fall time can spike in compressed knots and collapse in diffuse stretches only a kiloparsec away. Young massive clusters bloom like beads on a string along each streamer, some bound strongly enough to become long-lived globulars once the gas is gone. Metallicity maps tell a migration story. Inner disk gas torn free carries higher heavy element fractions than the outskirts, but mixing with cluster plasma and conductive interfaces can flatten those gradients along the arms, occasionally inverting them so that tail tips look oddly pristine. Where the nucleus is awake, radio jets and wide-angle winds punch cavities that channel hot gas into the head, tail wake, feeding back into the stripping and sometimes lighting up the tails in synchrotron, proving that relativistic particles can be exported like contraband from the core to the hinterlands. Piece the scene together across scales and a single circulation emerges. Spin-down energy from a neutron star becomes pairs and photons, which probe the electron froth between stars. Micro-impacts and sunlight script a planet's night chemistry, whose faint emissions encode winds, gravity waves, and magnetic gateways. A cluster, hot as a furnace, sculpts a disk into a jellyfish, yet in the very act of removal it ignites fresh nurseries where none should survive. Cosmic rays from shocks and tails seed ionization that alters cooling pathways. Dust ferried off the disk catalyzes molecule making in places a million degrees too warm by naive expectation. Magnetic fields connect head to wake, pulsar bow to galactic streamer, guiding energy and matter like rails. In that circuitry, pulse becomes weather, weather becomes starbirth, starbirth becomes metals, and metals ride new winds to start the cycle elsewhere, a fused heartbeat of physics and chemistry that turns a quiet patch of sky into a living laboratory. Each fragment of this cosmic tableau carries information about processes that bridge scales and epochs. The pulsar, spinning down through the drag of magnetic torque, reveals in its timing residuals the density structure of the cosmic plasma it illuminates, like a radar pulse bouncing off unseen walls of gas. Sometimes those signals arrive late not because of turbulence but because of planets or asteroids bound to the neutron star, tiny companions betraying themselves by tugging on the lighthouse with infinitesimal gravitational pulls. In rare cases, whole disks of debris encircle such remnants, creating dusty eclipses in the otherwise clock-perfect strobe, showing that even the most violent deaths leave fragments that attempt to coalesce into new structures. The crescent planet, glowing faintly at the limb, demonstrates chemistry's refusal to be quiet in the thin air above worlds. Atomic oxygen emits its emerald light as a byproduct of photodissociation and recombination cycles, but those cycles depend delicately on ultraviolet input, on magnetic shielding, and on the balance between heating and cooling at altitudes where one missed photon can flip the outcome of a reaction chain. Trace hydrocarbons or nitriles, lofted upward by upward transport, can become ionized, fragmented, and recombined into odd chains that last mere seconds before another photon erases them. Every flash and fade in the airglow encodes the rhythm of stellar flares, meteoroid infall, and magnetospheric surges, an atmospheric symphony that plays in wavelengths the eye cannot see but sensitive detectors can map. And further, the drifting jellyfish system continues to show how galaxies evolve not in solitude but in confrontation. When one of these tentacled wanderers dives deeper into a cluster core, it is not only stripped of gas but also pulled at by tides, the stellar distribution can warp, the dark matter halo can be heated, and sometimes dwarf companions, loosely bound, are left behind like crumbs in the wake. Within its luminous tails, clusters of newborn stars shine against the X-ray background of the cluster atmosphere, meaning that galaxies can export their stellar nurseries into the intracluster medium, seeding the space between galaxies with populations that may someday resemble free-floating globular clusters. Each of those clusters carries the metallic fingerprint of its origin, a memory of where in the galaxy it was torn away, ensuring that long after the parent disk is quenched, the echoes of its chemistry wander independently through the cluster's gravity well. Link the engines and the evidence, and a loop appears. The pulsar's relativistic wind carries not only electrons and positrons but also a pressure of pointing flux that can leak into nearby clouds. When that wind meets a clump, shock acceleration injects fresh cosmic rays whose ionization rate zeta/zeta sets the floor for molecule formation by freeing just enough electrons to catalyze H2/mathrm, H_2, H2 on dust and to drive ion neutral chemistry. In the crescent world's upper air, those same high-energy particles can tweak reaction pathways by splitting N2/mathrm, N_2, N2 and O2/mathrm, O_2, O2, seeding odd nitrogen and odd hydrogen families that alter cooling and emission, so the night glow brightens or dims in step with the ambient cosmic ray weather. Translate that logic outward and the tendrilled exile, the head-tail system with its long gaseous streamers, becomes a meter for cluster ecology. Shocks along its arms harden particle spectra, boosting non-thermal pressure that helps clouds resist ablation, while enhanced ionization shortens the chemical timescale for CO reassembly after shocks, letting cold pockets reappear where pure hydrodynamics would predict evaporation. The lighthouse's timing reaches even further. As pulses graze the tails, multipath scattering broadens them and carves a frequency-dependent tail in the radio profile. Measure that index and you diagnose the turbulence cascade in the stripped filaments, distinguishing subalfenic from superalfenic regimes and, by inference, how magnetic fields thread the jelly. Polarization vectors swing across the sky like iron filings around a bar magnet, revealing where field lines drape over the galaxy's nose and then align along the wake. Compare that map to the planet's auroral oval orientation and you glimpse a shared geometry, a preferred direction set by the cluster wind, the local interstellar field, and the pulsar's own motion, a triad that chooses where energy flows and where chemistry lights. Starbirth within the streamers writes its ledger in emission lines. H-alpha surfaces where ionized skins confront space, S2/H-alpha ratios climb in shock-dominated knots, O3, crescents track hard radiation near compact clusters, Faria, C2, and, OI, cool the interfaces where grains still survive. Millimeter CO ladders step up with density and temperature, and HCN or HCO spikes betray dense cores that should not exist in such a hot bath. Yet they do, because ram pressure, turbulence, and magnetic tension conspire to provide transient overpressures, microcradles that collapse quickly, forming bound clusters which, once gas-free, will drift through the cluster as orphan jewels. Their metallicities and alpha/Fe, \alpha/mathrm Fe, alpha/Fe, ratios will recall the radial zone of the mother disk from which they were torn. Decades later, those fossils will still whisper which arm of the tentacled migrant birthed them. On the crescent world, the chemistry keeps time with light. Day-night tides pump nitric oxide that glows in the infrared. Mesospheric OH bands sketch gravity wave trains launched by storms 100 kilometers lower. Atomic oxygen's green line swells after particle precipitation and wanes when solar EUV ebbs. Sodium from meteors traces the planet's micron-sized dust environment and varies with the parent stream calendar. Potassium lags because its ionization threshold differs, letting observers separate photochemical from collisional sources. During stellar flares, the ionosphere superheats and the F-layer lifts. The pulsar's beam, crossing at just the right hour angle, acquires a dispersive kink visible in a waterfall plot, an accidental joint experiment between a dead star and a living atmosphere. The nucleus of the stripped wanderer answers with intermittent fury. If a faint bar or lopsided torque channels leftover gas inward, the central black hole splutters on, radio knots walk outward at relativistic speeds, carving synchrotron lanes that overlay the ram pressure plume. X-ray cavities inflate where hot gas is displaced, entropy profiles flatten, cooling flows are reheated before they can condense. Feedback, usually blamed for quenching, here paradoxically brightens the wake by exporting cosmic rays and seed fields that stiffen the tails against thermal conduction. The head starves, the tail thrives. It is quenching by decapitation and regeneration by drift, morphology that only clusters can write. Even dust refuses to surrender. Grains eroded by sputtering in the million-degree medium survive inside dense knots long enough to catalyze H2\mathrm, H_2, H2 and to photoelectrically heat PDR skins. PAH features flicker in the mid-IR where UV from newborn stars bathes clump surfaces, and extinction maps reveal filigrees of dust braided through the streams. Where shocks race, silicon, and iron-bearing molecules spike from grain shattering, momentarily enriching the gas phase before recondensation. Those tiny solids, carried down the arms, will later seed planets if any tailborne clusters keep their gas long enough for second-generation disks to form, a speculative but tantalizing pathway by which a decapitated spiral could plant the raw materials for worlds into the intracluster night. Tie it all with numbers and the cycle closes. The pulsar's spin-down luminosity E/E sets a budget that you can chase into X-ray nebula, TeV emission, and ionization footprints. The planet's airglow brightness scales with column densities and reaction rates you can compute from cross-sections and local EUV. The Medusan migrant's tail length L tilde operator Galtstrapel /Sim V_/mathrm gal T_/mathrm strip L tilde operator of Galtstrip timestamps the stripping epoch, while the condition ICM2 2 pi g sigma star operator gas \row_\mathrm ICM v² 2 \pi g /sigma_star \sigma_. Mathrm to gas ICM2 2 pi g sigma star operator gas marks where gas detaches from the disk. Observables talk to each other. Dispersion, rotation measures across the tail's constrained field strength, which feeds the alphane speed, which sets the growth of shear instabilities, which governs how quickly cold clouds reform, which controls the CO brightness we measure. From a city-sized neutron star to a 100 kiloparsec plume, the same equations, conservation, diffusion, radiation, recombination, echo in different keys. And so pulse and chemistry, beacon and crescent, jelly and wake compose a living circuit. Energy born in a collapsed core becomes particles and fields that write weather in a planet's thin sky. A galaxy, rammed by a cluster wind, answers by turning its losses into luminous arms where stars are born against every expectation, and the faintest lines and delays we record, oxygen's green whisper, a microsecond of tardiness in a radio tick, a strand of H-alpha in a tail, are the receipts. Keep integrating, widen the band pass, and the receipts add up to a ledger, not a static picture, but a timed performance where gravity provides the stage, magnetism wires the lights, and chemistry, restless, opportunistic, endlessly recursive, steals the show. Phase offsets in the pulsar's beam sweep act like a stroboscope on plasma microphysics. When the lighthouse crosses clumps of enhanced electron density, the pulse broadens with a new -4 \new -4 new -4 tail. When it threads filaments where magnetic irregularities are anisotropic, the scattering becomes angle-dependent, and polarization exhibits tiny, frequency-locked wiggles that reveal the aspect ratio of turbulence eddies. Rotation measure synthesis turns those wiggles into a depth map of magnetized structure. Stack epochs and you get a time-lapse of field lines shifting as shocks pass, a magnetogram written not on a star but on the space between stars. Occasional nulling and mode changes hint that the acceleration zone itself is metastable, tipping between pair cascades like a double-well potential nudged by returning currents. When a glitch snaps the crust, the changing moment of inertia jerks the light cylinder and the whole radiation engine retunes in hours. The crescent world answers in lines and temperatures. At 90 to 100 kilometers, OH- bands cool the mesosphere while gravity waves from tropospheric storms fold the emission into zebra-striped fronts that move at tens of meters per second. At 200 to 300 kilometers, the red oxygen doublet brightens after particle rain and decays with lifetimes that clock the local collision rate. Sodium and potassium layers thicken after micrometeoroid streams, then erode as photoionization bites. LiDAR profiles would show a breathing metal sky, rising at dusk as tides lift isopycnals and settling before dawn. During starflare seasons, nitric oxide spikes in the lower thermosphere and re-radiates in the infrared, a safety valve that prevents runaway heating. The F layer lifts, recombination lags, and the planet's radio occultations reveal Chapman layers that warp in phase with the stellar EUV cycle. Even the night side is busy. Dissociative recombination of O2 plus \mathrm, O_2 caret plus, O2 plus and NO plus \mathrm, NO caret plus, NO plus feeds a budget that ends in photons, the dim, steady halo that turns the limb into a laboratory for radiative transfer. Downrange, the tentacled Voyager plows through the cluster wind and writes fluid dynamics in calligraphy. Where the ram pressure first overcomes the disk's gravity, cold gas separates into clouds that experience ablation at their flanks. The shear layer spawns Kelvin, Helmholtz billows whose turnover time sets the cadence of star-forming knots along each streamer. Magnetic draping around the galaxy's nose raises the effective alphane speed and aligns fields with the flow, throttling cross-field conduction. The field length grows, conduction saturates, and cold cores persist longer than naive evaporation arguments allow. Shocked skins ionize and glow in H-alpha and N2 zones with fast shocks and hard spectra push, O3/H-beta high, mixing layers brighten, OI, and S2 mm ladders show CO surviving where the bath sits at tens of millions of Kelvin because dense clumps self-shield and because dust, sheltered inside, keeps catalyzing H2 \mathrm, H_2, H2. CO and CH3_33 OH spike where grains are shattered and sputtered, fleeting chemical fireworks that mark recent shocks before molecules refreeze. Starbirth in exile leaves fossils. Compact, high-pressure clusters bead the wake like a string of lanterns. The most bound will outlive their gas and travel as ultra-compact dwarfs through the cluster potential. Their alpha/Fe \alpha/mathrm Fe alpha/Fe, and age spreads preserving a timestamp of the stripping episode. Ionizing photons leak more easily from these ram-made nurseries than from settled disks. Lyman continuum escape fractions can rise because turbulence and shear punch low column channels. so tail H2 regions act as lanterns that harden the intracluster radiation field. Cosmic rays from bow shocks and supernova remnants in the wake ionize just enough to alter chemistry, raising the HCO+/HCN/mathrm, HCO+//mathrm, HCO+/HCN ratio and accelerating CO reassembly after each shock passage. Non-thermal pressure stiffens the clumps against further shredding, buying time for gravity to finish its work. The nucleus of the decapitated spiral is a coin toss. If torques and asymmetries funnel leftover gas inward, a flickering accretion episode launches radio knots that ride ahead into the cluster wind, their synchrotron ridges draped over the larger ram pressure plume. X-ray cavities inflate where relativistic plasma displaces the hot atmosphere, entropy profiles flatten, cooling flows stall, and yet, paradoxically, freshly energized particles leak into the wake and light the streamers at low radio frequencies. If the core stays quiescent, quenching proceeds by strangulation, the halo supply is cut, star formation fades from the head inward, and the luminous hair glows on as an afterimage of momentum transfer, a comet tail of stellar nurseries drifting behind a starving face. Observationally, the whole triad knits together across bands. Low-frequency arrays map the aged electrons in the wake and measure spectral curvature where reacceleration occurs. Millimeter interferometers pick out clump kinematics and CO excitation ladders. Integral field spectrographs draw BPT mosaics over the streamers, separating shocks from photoionization. X-ray telescopes register the hot bath in which the drama swims and the cavities whose edges match radio rims. Meanwhile, pulsar timing arrays fold into beacons ticks to subtract gravitational wave backgrounds and still recover microsecond plasma weather. Simultaneous line of sight to the tails turns each arrival time residual into a probe of density fluctuations in the very filaments where stars are forming. Radio occultations of the crescent limb produce electron density profiles whose dawn-dusk asymmetry correlates with the cluster wind direction inferred from the jelly's head-tail orientation, a geometric rhyming across 20 kilometers, 10,000 kilometers, and 100,000 light-years. Even dust keeps the score. PAH bands flicker where UV from wake-borne OB associations grazes clump surfaces, mid-IR colors swing with radiation hardness, far-IR continuum traces the embedded phases that lines miss. Grain size distributions evolve under sputtering, but the densest knots preserve enough large grains to maintain photoelectric heating and to catalyze H2/mathrm, H_2, H2, downstream, where turbulence relaxes, recondensation and coagulation begin to rebuild the inventory. Those solids are ferried into the intracluster medium along with newborn clusters. If any second-generation disks emerge around tailborne stars, planetesimals will inherit the radiometallicity memory of the lost spiral, worlds literally forged from a galaxy's shed hair. Numbers close the loop. The tail length timestamps the stripping epoch. The condition ICM2 greater than or equivalent to 2 pi g sigma star operator gas \rho_\mathrm ICM v squared /trim2 /pi g /sigma _\star /sigma _\mathrm gas ICM2 greater than or equivalent to 2 pi g sigma star operator gas marks detachment. The pulsars E budgets the non-thermal glow and ionization footprints. The planet's airglow intensities solve for column densities and reaction rates under known cross-sections. Dispersion and rotation measures across the wake fix field strengths and coherence scales. Those feed Alfvén speeds and Richardson numbers that determine which shear layers roll up and which stay laminar. That feeds the clump survival time, which sets the CO brightness and cluster birth rate that far-IR and H-alpha actually measure. A city-sized engine, a thin shell of atmosphere, and a decapitated spiral converge on the same conservation laws: mass, momentum, energy, charge, played in different keys, leaving receipts in photons, lines, and delays. Follow those receipts and you watch energy change costume. Spin becomes pairs and pointing flux, becomes shocks and cosmic rays, becomes ionization and chemistry, becomes cooling and starbirth, becomes metals and dust, becomes planets, while the faint green whisper of oxygen at a limb, the soft radio purr of aged electrons in a streamer, and the microsecond hesitation of a radio tick together certify the transaction. Over long baselines, the lighthouse's spin is not a simple power law but a palimpsest of interior physics. Hall drift reshapes the crustal field, ambipolar diffusion in the core slides flux tubes through superfluid neutrons, vortex pinning and unpinning trigger glitches that dump angular momentum from the superfluid to the crust. Each event leaves an exponential recovery whose timescales whisper about mutual friction and the coupling of layers you cannot otherwise see. The particle cascade above the magnetic poles is just as talkative. Pair multiplicities rise and fall with magnetospheric state changes, altering the radio beam's brightness, temperature, and the high-energy cutoff. Even the faint, off-pulse emission matters. It traces return currents that close the circuit and seed a compact bow shock, a miniature comet riding ahead of a star the size of a city, marking the local medium's density with its standoff arc. The crescent world beneath that sweep is not static either. At the exobase, thermal escape competes with non-thermal routes, charge exchange with pickup ions, sputtering by precipitating particles, dissociative recombination that tosses fast neutrals outward. Nightside recombination paints a dim auroral drizzle even far from the poles, and the ionosphere's dynamo winds drive E times B drifts that shuffle plasma along equipotential contours set by the interplanetary field. Airglow tomography, imaging narrow lines like the 557.7 nm and 630 nanometers oxygen emissions at multiple limb angles, lets you invert for winds and temperatures, turning the planet's thin sheen into a three-dimensional weather map. When meteoroid streams pass, sodium and potassium flare into a double halo. When a stellar superflare erupts, nitric oxide spikes become the atmosphere's radiative safety valve, cooling the thermosphere in infrared while radio occultations reveal Chapman layers lifted and warp like sails. Far beyond, the Medusan Voyager writes its own chronology in light. Early in its plunge through the cluster, ram pressure scours outer disk gas first, so the newborn clusters in the longest streamers carry the metallicity of the outskirts. Deeper in, inner disk gas is peeled and the wake's chemistry grows richer. Tidal harassment and minor encounters can pre-loosen that gas, pre-processing, so by the time the cometary spiral meets the cluster headwind, much of its reservoir sits at the brink of removal. A magnetic draping layer piles up ahead of the disk, boosting field strength and aligning lines with the flow. Cross-field conduction throttles, Kelvin, Helmholtz rolls lengthen, and dense clumps outlive naive evaporation arguments. Along the wake, shocklets and mixing layers stitch a ladder of phases from million-degree X-ray skins through warm ionized filaments to cold, self-shielded molecular pockets where CO, HCN, and HCO prove that chemistry regroups under pressure. Young massive clusters stud the tendrils like beads. The most bound will evolve into intracluster wanderers, their alpha/Fe, \alpha/\mathrm Fe, alpha/Fe, patterns and ages archiving the strip epoch long after the parent disk fades. Sometimes the nucleus of the plume-bearer answers with a pulse of its own. Gas torqued inward by asymmetries lights a briefly active core whose radio knots ride the same wind and overlay the larger plume in synchrotron, inflating X-ray cavities that flatten entropy profiles. Feedback that would quench a field spiral instead exports cosmic rays and seed fields into the tail, stiffening clumps against ablation and, paradoxically, prolonging star formation in exile. If the core stays quiet, starvation proceeds from the head inward, the galaxy slides toward an S0 remnant while its luminous hair thins and the intracluster light grows, enriched by tail-borne stars and dust grains that survived by hiding in the densest knots. The triad talks across messengers. A fast radio burst grazing the filaments would pick up an extra dollop of dispersion and a distinctive scattering tail, fingerprinting density fluctuations and turbulence anisotropy in the very strands where clusters are forming. Background polarized sources behind the wake accumulate rotation measure, tracing field strength and coherence lengths that millimeter interferometers can compare to clump kinematics. The beacon's timing residuals, taken while its line of sight schemes the streamers, register microlensing by overpressured pockets and refractive wander from turbulent cells, simultaneous integral field spectroscopy in H-alpha, O3, S2, and OI, sorts shocks from photoionization on the same patches the radio probes. Even the planet joins the network. When the jelly's tail and the crescent's limb share nearly the same sightline, the pulsar's pulses traverse both media, letting you separate a planetary ionosphere's dispersive wink from a filament scattering curl by their frequency scalings. Given enough time, outcomes bifurcate but the ledger balances. The lighthouse spins down, its wind fades, and its nebula cools, but the energy it spent has already written weather in a planetary sky and lit shocks in a galactic plume. The crescent world's upper air thickens and thins to the rhythm of its star and meteors, leaking atoms to space even as chemistry rebuilds molecules each night. The tentacled migrant loses its head supply but gains a diaspora, clusters, dust, and metals folded into the intracluster medium, while its core drifts toward quiescence. What remains are receipts in many bands, a softened radio spectrum along the wake, a lattice of emission line ratios that only shocks can explain, a faint green ring on a limb, microseconds of lateness in a tick. Follow them and the scene resolves into a single conservation story: spin to particles, particles to fields, fields to shocks, shocks to chemistry, chemistry to stars, stars to metals, metals to worlds, pulse and chemistry braided from 20 kilometers to 200,000 light-years, a coherent machine humming in vacuum. Numerical experiments replay the scene with magnetized gas and gravity turned up to honest levels, push a spiral through a bath at Mach 2 to 3, set intracluster densities around 10⁻⁴ 10 carat, -4, 10⁻⁴, 10⁻3 cm -3 10 carat, -3, \\mathrm, cm carat, -3, 10⁻3 cm -3. Let the disk spin and tilt by a few tens of degrees, and a streamer-crowned pilgrim emerges on 100 megayear timescales. Face-on plunges peel layers like pages, edge-on dives carve long, coherent ribbons. Tail lengths of 50 to 150 kpc timestamp the orbit, while not spaced by a kiloparsec or two trace the turnover of Kelvin, Helmholtz billows. Include fields and the picture sharpens. A draped sheath at the galaxy's nose amplifies BBB to tens of mu/mug, suppressing cross-field conduction and giving cold clumps a reprieve from sputtering that would otherwise erase dust within operator 107/sim 10 carat 7 operator 107, 10810 carat 8108 years. In that breathing room, CO reforms behind shocks, HCN lights up the densest pockets, and PAH features flicker where newborn OB stars sandblast their cocoons. Chemistry takes instructions from shocks and radiation at once. In mixing layers, OI/mathrm O/O 6300A and S2/mathrm S/2 SI rise as neutral ion traffic heats interfaces. Faster shocks drive O3/H beta/mathrm O/3 /mathrm H/beta OII/H beta high and flash Na3/mathrm Na/3 Na3 in the blue mid-IR C2/mathrm C/2 CII and Fe2/mathrm Fe/2 Fei mark freshly liberated grain material. Millimeter ladders step up with density as COJ equals 32J equals 3/2 2J equals 32 and J equals 43J equals 4/2 3J equals 43 brighten where compression is strongest. Ratios like HCO plus/HCN/mathrm, HCO carat plus, /mathrm, HCN, HCO plus/HCN and C2/CO/mathrm, C/2 /mathrm, CO, the CII/CO swing with ionization rate zeta/zeta, a knob that cosmic rays from bow shocks and tail supernovae happily turn. Push zeta/zeta to 10⁻16 10 carat, -16, 10⁻16, 10⁻15 S-1 10 carat, -15, \mathrm, S carat, -1, 10⁻15 S-1 and cooling pathways accelerate, shortening the time from shredded cloud to star-forming clump. Let it fall and molecules languish in semi-atomic limbo. The tentacled wanderer becomes a chemistry seminar written across 50,000 light-years. Kinematics writes margins in the same notebook. Integral field cubes reveal velocity shears of 100 to 300 km/s across streamer widths, with line widths broad where eddies bite and narrow in the quiet cores where clusters are coalescing. Down each filament, metallicity gradients flatten as intracluster plasma dilutes inner disk gas. Occasionally the slope inverts, leaving pristine tips whose young stars carry unexpectedly low oxygen. Those stars often gather into compact, high-pressure clusters of 10410-4104, 106M10-6/M_/ODAT106M. The best bound will outlive gas expulsion and wander the cluster as ultra-compact fossils, intracluster jewelry that remembers the radius inside the parent disk where it was born. Their alpha/Fe, \alpha/\mathrm, Fe, alpha/Fe, patterns and age spreads archive the strip epoch long after the cometary spiral settles into a gas-poor remnant. Magnetism keeps score in polarization. Rotation measure skins wrap the comet head, then run parallel to the wake. Spectral indices steepen away from the head and flatten where reacceleration sneaks in. Low-frequency halos betray aged electrons that have drifted off the main lanes. Stack Faraday tomographies with tail-crossing sightlines to background sources and a 3D map of field coherence falls out, one that feeds back into stability. Higher alphane speeds lengthen roll-up times, extend clump lifetimes, and modulate how quickly CO can rebuild after each shock pass. Even the radio beacon nearby participates as a probe. Dispersion measure in PCCM-3 PC/CM-3 PCCM-3 climbs by a few tenths when the line grazes a dense streamer. Rotation measure wiggles in step with the filament's field, and multipath scattering imprints a new -4 -4 tail whose amplitude clocks the turbulence anisotropy. A microsecond of lateness in the tick becomes meteorology for a river of intergalactic gas. Closer to home, the crescent world keeps up its quiet light show. Scale heights in the thermosphere balloon with EUV input, Chapman layers lift at noon and slouch at night, OH-minal bands draw gravity wave trains born 100 kilometers lower, the 557.7 nm oxygen line brightens after particle rain and slackens as recombination wins. Sodium and potassium halos wax after meteoroid streams, their lifetime set by photoionization thresholds that let the two metals walk out of phase. Nitric oxide spikes during stellar tantrums and then cools the thermosphere in infrared, a self-defense reflex of thin air. Run radio occultations across the limb and the planet yields electron density profiles that sway with the same wind direction the streamer-crowned pilgrim announces on megaparsec scales, a rhyme between a sky only hundreds of kilometers thick and a tail 100,000 light-years long. Feedback plays a double game at the decapitated core. If torques and lopsidedness funnel residue inward, a flicker of accretion launches radio knots that overlay the larger plume in synchrotron, inflate X-ray cavities, and export relativistic particles into the wake. Quenching at the head, stiffening in the hair, starvation by design, resilience by accident. If the nucleus stays quiet, strangulation proceeds as the halo supply dries, star formation fades from the face inward while the luminous hair persists as an afterimage of momentum transfer. Either way, the intracluster medium wins metals, dust, and bound clusters. Enrichment proceeds not only through the biggest central engines but through a diaspora of RAM-made nurseries. Predictions tighten the loop. Tail H2 region should leak ionizing photons more freely than settled disks, raising local escape fractions because turbulence and shear punch low column channels. CO and CH3_33OH ought to spike at shock interfaces where grains shatter. CI/mathrm, C/CI, lines should bridge the atomic molecular handoff in mixing layers. FARIR, OA/mathrm, O/OA, and C2/mathrm, C/2, the CII, should overcool clump skins as OB associations age. Radio spectra must curve with distance as losses steepen, then flatten where reacceleration bites. Faraday depth distributions should show a narrow drape at the nose and a wide, braided spread down the wake. Fast radio bursts seen through the streamers will pick up extra dispersion and a distinctive scattering kernel, a fingerprint of density inhomogeneities at parsec scales in a place no other probe can touch. Each test is a receipt waiting to be printed. And still the ledger balances from small to vast. A city-sized dynamo sloughs spin into pairs and fields, those fields and particles ignite shocks in chemistry, chemistry knits clouds that collapse into stars, stars forge metals and dust, dust seeds molecules and, eventually, worlds. The comet-tailed migrant, call it the Medusan exile, the head-tail pilgrim, the streamer-haired voyager, trades its breath for a diaspora that lights a cluster's darkness. The crescent's limb whispers green and red as reactions finish, the pulsar's tick hesitates by microseconds as it threads filaments, the tentacles glow in H-alpha, UV, and millimeter lines as new clusters bead along their lengths. Follow the photons, the delays, the ratios, and a single conservation story ties 20 kilometers to 200,000 light-years, pulse into weather, weather into birth, birth into metals, metals into planets, a circuit closing and restarting wherever gravity, wind, and magnetism agree to wire the night. Over still longer arcs, the comet head spiral records its own thermodynamic memoir in entropy and pressure. The hot bath that scours it, the cluster's atmosphere, follows a cooling function that spikes near 105.5 10 carat, 5.5, 105.5, 106 K 10 carat, 6, \mathrm, K, 106 K, wherever stripped gas is mixed down into that window, thermal instability bites. The field criterion decides which parcels condense. If the cooling length shrinks below the scale of conduction, droplets form. If magnetic tension stretches heat flux along field lines and throttles it across, condensation proceeds in filaments aligned with BBB. Brzezinski anisotropic viscosity turns shear layers into laboratories for mirror and fire hose instabilities. Microturbulence seeds the cascade that broadens lines to a few tens of km/s even where bulk flows are calm. In those narrow corridors of parameter space, cold cores survive, CO reassembles behind shocklets, and the stream-remained wanderer writes a ladder of phases from keV gas to tens of K dust, every rung visible to a different instrument and every rung obeying the same conservation laws. The lighthouse keeps behaving like a scalpel for plasma structure. As its beam threads the wake, dispersion, dm\mathrm, dm, and rotation, rm\mathrm, rm, measures track electron density and line-of-sight field, but the combination with scattering time τsc is proportional to nu-4 \tau_\mathrm /propto/nu-4. τsc is proportional to nu-4 pins the turbulence geometry. A shallow frequency slope hints at elongated eddies and subalfvenic cascades, a steeper slope confesses to isotropic, superalfvenic froth. Occasional refractive wander, a slow meander of the pulse-arrival centroid, betrays overpressured clumps acting as weak lenses, while sudden diffractive twinkling indicates AU-scale sheets at mixing interfaces. Stack these diagnostics against emission line ratios in the same pixels and you tie microphysics to chemistry, where S2/H-alpha is high and O3/H-beta modest, shock, mixing layers dominate and the radio tick grows the longest tail. The crescent world, razor-lit at the limb, becomes a chronometer for upper atmosphere kinetics. Non-LTE populations in O, 1 to the power of 11s, and O, 1 to the power of 11d, govern the green and red lines. Collisional quenching at 90 to 110 km sets their altitudes, and the ratio of the two lines clocks density as faithfully as a barometer. Migrating diurnal and semi-diurnal tides slide Chapman layers up and down by tens of kilometers, E times B drifts steer plasma across longitudes, cusp precipitation writes proton aurorae that brighten without warning. During meteor streams, the sodium sky swells into a double layer, an ablation-fed sheet and a gravity wave-piled call above it, while potassium lags because its ionization threshold draws a different curve against EUV. Every one of these adjustments adds or subtracts electrons from the path the pulsar's tick takes, turning the planet into an accidental interferometer whose phase screen you can invert if you time the strobe and scan the limb. Further down the wake, the head-tail peregrine braids kinematics and enrichment. OB associations ignite within overpressured knots. 10 million years later, their first supernovae lace the filaments with alpha/alpha elements, pushing alpha/Fe, \alpha/\mathrm, Fe, alpha/Fe, high before type Ia iron reigns in on 100 megaclocks. Dust destroyed at a shock front resurges in sheltered cores by accretion on grain seeds, PAHs, fragile and hard UV, reappear where columns thicken and excitation softens. Escape fractions for Lyman continuum photons climb because shear and turbulence punch low NHN_\mathrm H, NH channels, tail H2 regions leak with an efficiency field spirals rarely achieve, so the streamer-lit intracluster space hardens by degrees. Some bound knots overshoot, cluster, and land in the ultra-compact dwarf regime of 106 M10/6 \M_\O at 106 m and radii of a few tens of parsecs, liberated from gas. They will orbit for gigayears as intracluster jewelry, each a time capsule of the radius and epoch of stripping. Even the orbit writes fingerprints. As the plume-bearer rounds pericenter, Coriolis deflections and changing wind vectors bend the tail, a gentle S-curve in the streamers timestamps the phase of the plunge, while a gradient in tail width flags where the ram pressure crest passed. Stars, feeling only gravity, decouple and sail on. Gas, feeling the headwind, lags, so the offset between stellar isophotes and gaseous hair gives a dynamical yardstick you can read without touching. In multiphase maps the hot envelope bows at the nose, the warm ionized skin peels away just behind, and the cold clumps trail last, 3 layers of a shock umbrella whose curvature recites the pressure ratio between galaxy and bath. Back at the city-sized dynamo, interior physics continues to leak into timing. Vortex pinning in the neutron superfluid builds a reservoir of angular momentum. When a forest of pins unzips, a glitch jolts the crust and the braking index detours for weeks. Hall drift shuffles crustal field patches on 10310/3103, 10510/5105 year scales, retuning the accelerator above the poles and toggling pair multiplicity. The radio beam's polarization angle swing and the gamma/gamma ray cutoff both flinch in sympathy. Off-pulse emission sketches return currents that close the magnetospheric circuit. Their faint synchrotron halo, seen with hard X-rays, marks the termination shock where pointing flux turns to heat, an energy budget you can chase from E to TeV by adding up photons and leptons. Tie the ledger numerically and the couplings lock. A representative RAM pressure pram_operator icm2p_\mathrm RAM /sim/rho_\mathrm ICM v2 pram_operator icm2 of 10-11 10-11 10-11 10-10 dyn cm-2 10-10 \mathrm dyn /cm-2 10-10 duncm-2 exceeds the restoring force 2 pi g sigma star operator gas 2 /pi g /sigma _star /sigma _mathrm gas 2 pi g sigma star operator gas beyond a few kiloparsecs, so gas detaches on operator 108 /sim 10-8 operator 108 year timescales. Tail lengths of 50 to 150 kpc follow for v operator 1000 kms-1 v /sim 1000 \mathrm km /s-1 a v operator 1000 kms-1. Shock compression by factors of 3 to 10 drives post-shock densities to 10 to 100 cm-310, 100 \mathrm cm-3 10 100 cm-3, shrinking freefall times to 5 less than 5 mir and plausibly explaining bead spacing along filaments. Cosmic ray ionization rates zeta operator 10 -16 /zeta /sim 10 -16 zeta operator 10 -16 10-15s-1 10-15 \mathrm s -1 10-15s-1 are enough to lift HCO plus /HCN \mathrm HCO plus /mathrm HCN HCO plus /HCN accelerate CO reassembly and keep clumps marginally ionized so ambipolar diffusion does not erase magnetic support too quickly. On the limb, O, 1 to the power of 11s, and O, 1 to the power of 11d, intensities of a few kilorayleigh imply electron densities of 10410-4104, 105 cm-310 5 \mathrm cm -3 105 cm-3 in thin layers and temperatures of 180 220180 220180 220 K where OH- bands cool the mesosphere. Tiny changes in EUV or particle rain swing those values measurably, which the pulsar's timing residuals will confirm as a few tenths pcm-3 \mathrm pc \cm -3 pccm-3 of dm wiggle if the geometry lines up. Predictions fall out like receipts waiting to be stamped. Low-frequency radio maps should show spectral steepening with distance from the head and localized flattening where reacceleration in shocklets bites. Faraday tomography should reveal a narrow drape at the nose and a braided distribution down the wake. Integral field mosaics will find S2/H-alpha elevated and O3/H-beta patchy in mixing layers, mid-IR, C2, \mathrm, C2, CII, and Fe2, \mathrm, Fe2, Fei should spike where grains have been recently shattered, Ci, \mathrm, C/Ci, should bridge atomic to molecular zones in the same pixels where CO ladders climb. Fast radio bursts skimming the filaments will pick up extra dispersion and a scattering kernel broader than in field sightlines, with angular broadening that diagnoses turbulence anisotropy. The crescent limb's 557.7 nanometers per 630.0 nanometers ratio will swing with particle precipitation, and radio occultations will register dawn-dusk asymmetries that correlate with the head-tail orientation of the plume-bearing pilgrim on the same sky. What looks, at first glance, like three unrelated actors, a dead star's metronome, a whisper-thin atmospheric ring, and a streamer-crowned exile, resolves into a single electrical diagram of the universe. Spin pours into fields and pairs draw shocks, shocks sculpt chemistry, chemistry cools gas into stars, stars mint metals and dust, dust catalyzes molecules, molecules seed worlds, and all along, photons, polarizations, and microlate ticks keep the books. Call the plume-bearer a jellyfish, a head-tail comet, a ram-sheared disk, a cluster-plunging Voyager, the name shifts, the physics persists, and the ledger closes, pulse into weather, weather into birth, birth into memory, memory into matter. As the streamer-crowned pilgrim plows onward, radiation hardens and softens along its arms like breaths. Young OB knots in the wake pour out far UV that skins clumps into photodissociation regions where C2, \mathrm, C2, CII, and O, \mathrm, O, carry away heat, inside, self-shielded layers nurse H2 \mathrm, H_2, H2 that is invisible to CO until densities and dust columns cross the threshold for carbon to settle into molecules. This CO dark H2 \mathrm, H_2, H2 swells the true mass of the filaments beyond what millimeter ladders alone would guess, and when shocks pass, the hidden reservoir flashes briefly into CO as temperature and density climb, a chemical aurora matching the optical one you see from the planet's limb. Grain alignment in those skins, twisted by radiative torques, polarizes mid-infrared light, rotate a polarimeter and you read the direction of the field thread by thread along the jelly's hair, then compare the vectors with the Faraday tapestry from low-frequency radio to recover not only geometry but depth, magnetism rendered tomographic by dust and electrons acting in chorus. The lighthouse contributes a quieter but relentless pressure, a fog of relativistic leptons that drifts into the local medium and salts the chemistry with a baseline ionization. In the planet's high air, this raises the floor on odd nitrogen families, changing how efficiently nitric oxide can cool surges after particle rain. In the wake, the same background nudges reaction networks toward HCO plus \mathrm, HCO plus and against fragile species, shortening the path from shattered cloud to reassembled molecule. Even neutral atoms do not stay idle. Charge exchange with fast ions scribbles wings on line profiles, a microscopic handshake you can read in the skew of OI, or the shoulders of H-alpha\mathrm, H\alpha, where the tail's warm layer confronts the million-degree bath. Each skew maps a thin shock, and the spacing of skews along a filament clocks the eddy turnover that sets the cadence of bead-like clusters. Geometry keeps revealing itself in coincidences you can exploit. When a background quasar happens to sit behind a draft of the streamer, its spectrum picks up a forest of narrow absorbers, Ni from dustier pockets, Ca2 from shock-liberated skins, Ci\mathrm, C\Ci, bridging the atomic, molecular seam, while the same pencil beam, at radio, accrues rotation measure and a pinch of dispersion. If a fast radio burst slices the exact lane, its scattering kernel fattens and its polarization swings, giving an instantaneous, 1-pixel audit of density contrasts and magnetic coherence on parsec scales. Hours later, the lighthouse's millisecond ticks repeat the probe at lower brightness but higher cadence, turning an accident into a time series. Layer these with integral field mosaics and the comet-tailed wanderer, ram-sheared disk, Medusan exile, streamer-haired Voyager, stops being a picture and becomes a solved set of boundary conditions. Closer to the crescent, photochemistry and dynamics braid into subtle patterns the eye would miss. Dayside EUV lifts the F layer and primes recombination that will glow red along the nightside limb. Tides pump the ionosphere into migrating crests that drift westward, gravity waves launched by distant storms steepen and break, and the OH bands trace their surf in faint sawtooth fronts. Micrometeoroids feed the sodium sky into a ring so thin that it brightens after each stream and dims with photoionization on a timetable that betrays the parent comet, potassium, with a different threshold, lags, and their phase difference lets you untangle photons from impacts. Auroral ovals flicker when reconnection opens magnetic doors, proton arcs flare where the cusp drinks directly from the wind, the green oxygen line fattens when metastable O1 to the power of 11s, wins its race against quenching, and slims when collisions take the prize. A single radio occultation turns those whispers into a vertical profile, a run of them across local time becomes a meteorology of the thin, and the lighthouse's DM residuals add the faintest of exclamation points when the column changes by only a breath. Deep in the plume, enrichment and feedback swap roles with every generation. First, OB associations carve cavities and lace the lane with alpha/alpha elements, then type Ia supernovae arrive on longer clocks and salt iron into the mix, dust regrows by accretion in calm pockets, PAHs reappear as UV softens, and the mid-IR warms as photoelectric heating resumes. Where the head flickers into activity, radio knots overlay the wake with fresh synchrotron, X-ray cavities inflate and cool rims sparkle in O2/mathrm O/2 OII, and N2/mathrm N/2 NII, where the core stays mute, strangulation proceeds and the luminous hair persists as a drifting nursery, a comet tail of clusters that will bequeath intracluster light to the space between galaxies. The most bound knots cross the threshold into ultra-compact dwarfs, their pressure-forged stars locked so tightly that gas expulsion cannot unbind them. Eons later they will still circle the cluster as jeweled fossils whose alpha/Fe/alpha/mathrm Fe, alpha/Fe, ages, and internal dynamics recite the radius and epoch of stripping long after the parent disk is a memory. Even the million-degree bath is not an idle backdrop. Sloshing from past mergers sways the headwind, weak shocks ripple outward from the brightest cluster galaxy and retune ram pressure by gentle percentages, cold fronts fold the entropy map into contact discontinuities that the ram-sheared disk must cross. Each crossing imprints a kink in the tail, a sudden change in curvature or width that timestamps the environment's own weather. Magnetic draping at the nose grows and relaxes as the bath's field rotates with eddies, cross-field conduction throttles accordingly, the field length swells or shrinks, and the survival time of cold clumps tracks the same beat. Put it all together, polarization vectors from dust alignment, Faraday depth from background sources and the beacon, kinematics from integral field cubes, chemistry from line ratios, continuum from far IR and radio, and the streamer-haired Voyager yields a 4D reconstruction, space, time, field, and flow, solved not by a single instrument but by the choir. In the end, the ledger is a choreography of conversions. Spin decays into pointing flux and pairs, those become shocks and turbulence. Shocks and turbulence sketch chemistry, chemistry cools gas into stars, stars forge metals and make dust, dust hosts molecules, molecules assemble clouds, clouds collapse into clusters that sometimes survive as sovereign citizens of the intracluster night. The crescent's limb keeps time with faint green and red whispers, the lighthouse's tick hesitates by microseconds as it grazes filaments and breathes through ionospheres, the Medusan exile, head, tail pilgrim, plume-bearing comet, ramshorn disk, streams H-alpha, UV, and millimeter light as new clusters beat its arms. Follow the vectors, the ratios, the delays, and the spectrum curves, and the disparate actors fuse into one machine, pulse into weather, weather into birth, birth into memory, memory into matter, matter into worlds, worlds back into winds, an economy of energy and elements that hums from a neutron star's 20-kilometer engine to a 100-kiloparsec river of stars. On longer timescales, the wake-braided commuter negotiates gravity's tides as much as the wind. Pericenter passages tilt the disk, bar torques bloom, and the stellar orbits precess into subtle warps while the gaseous hair continues to stream behind. Where the cluster's potential steepens, the tail shears into multiple lanes, a fast, lightly mixed ribbon hugging the axis, a broader, shock-laced sheet where the bath and the outflow trade momentum, and a necklace of dense knots that keep their identities for tens of mere. In each knot, pressure climbs to values more familiar inside starburst nuclei than in intergalactic space, and the initial mass function nudges top-heavier than in quiet spirals, a statistical whisper that compression and turbulence sculpt which stars are born. The lighthouse keeps time with the orbit. As the ramshorn spiral, call it the cluster surfer, swings behind denser caustics of the intracluster medium, dispersion and rotation measures rise by just enough that the pulsar's millisecond ticks show a soft, periodic swell. Between those crests, multipath scattering shrinks, and the pulse profile sharpens, implying a corrugated bath whose density peaks and magnetic folds ride the galaxy's path like swells under a ship. When the beacon glitches, a jolt in its braking index resets the metronome, folding timing data through the jelly's Faraday tapestry separates interior neutron star physics from the weather of intergalactic gas, a clean subtraction problem solved by a dead star and a drifting comet disk working in tandem. Closer to the crescent world, escape becomes a slow leak, not a catastrophe. Pick up ions strip atoms from the exobase, charge exchange writes faint high-velocity wings into hydrogen lines, and the planet grows a diaphanous tail invisible except in resonant scattering. The sodium sky swells after meteoroid streams and drapes downwind, its column density tracks the microdust environment like a seismograph of space grit. During stellar tantrums, nitric oxide surges and cools the thermosphere in infrared, a radiative break that prevents runaway heating. After the storm, radio occultations find Chapman layers slumped by tens of kilometers, and the lighthouse's dispersion budget relaxes by a hair, microphysics logged as microseconds. Inside the streamer choir, radiation pressure and gravity argue over dust. Big grains, cushioned in dense clumps, ride with the gas, small grains, hammered by UV and hot ions, erode unless they hide in shaded cores. Where OB associations ignite, photoelectric heating on grain surfaces pumps energy into PDR skins, C2, and, OI. Gulp the excess, and mid-IR PAH bands flicker as tiny aromatics survive by darting between photons. Shocks that shred grains also prime chemistry, silicon monoxide spikes, methanol flares, and then, in calmer eddies, metals recondense and the ladder from atomic to molecular resets. CO dark H2 backslash mathrm, H_2, H2 lurks in envelopes the millimeter lines under cell, only, Ci, and, C2, admit the hidden mass that gravity already knows is there. Kinematics threads the narrative with measurable knots. Along the plume-bearing wanderer, line widths widen where shear feeds eddies and narrow where self-gravity has taken over, velocity centroids drift by hundreds of km/s across a tail's width, a gradient steep enough to roll Kelvin, Helmholtz billows on mere clocks. In those rolls, shocklets compress gas by factors of a few, trimming the freefall time below the interval between eddies so star formation can outrun shredding. Young clusters then light H2 bubbles whose leakage is higher than in settled disks because turbulence has already drilled low column channels. The wake, paradoxically, becomes an efficient exporter of ionizing photons into intracluster space. The head's fate forks but remains legible. If asymmetries torque residue inward, a brief meal for the black hole launches radio knots that overlay the larger RAM plume, carve X-ray cavities, and inject cosmic rays that stiffen clumps downstream, quenching at the face, resilience in the hair. If the core stays quiet, strangulation empties the pantry slowly, the stellar disk drifts toward an S0, and the luminous tendrils fade as gas is spent into stars and the rest diluted into the intracluster medium. Either way, the diaspora persists, bound clusters, dust, and fresh metals join the diffuse glow between galaxies, a contribution to intracluster light that a comet-tail spiral, plume-bearer, streamer-haired pilgrim, Medusan exile, makes not by exploding but by shedding. Neutrals, ions, and leptons share the page with photons. Hadronic collisions in the densest shock seed faint pi0 decay gamma rays, inverse Compton halos bloom where aged electrons meet starlight and the microwave background, low-frequency radio maps curve spectrally with distance from the head, then flatten where reacceleration nips losses. Faraday depth cubes unwrap magnetic coherence lengths that rise near the nose and braid down the wake. Dust polarimetry at mid-IR, twisted by radiative torques, gives plane-of-sky field angles that agree or disagree with the radio, settling debates about 3D geometry. Stack all of this with integral field mosaics, H-alpha, S2, O3, OI, and the boundary layers between hot bath and cold cores stop being metaphors and become measured thicknesses in parsecs. Back at the city-sized dynamo, interior matter still dictates exterior light. Nuclear pasta in the inner crust pinches and releases superfluid vortices, each unpinning sends a whisper through timing that recovers on days to weeks, a relaxation curve whose shape constrains mutual friction between neutrons and lattice. Hall drift then rearranges magnetic stresses over millennia, tuning pair cascades and, with them, the spectrum of the beam and the hardness of the wind. Off-pulse X-rays mark the termination shock where pointing flux thermalizes. TeV photons close the ledger via inverse Compton on ambient fields, numbers that balance against E with a neatness only nature's bookkeeping can maintain. What began as 3 actors remains one machine. The ram-torn spiral exports metals, dust, and clusters into the cluster night. The crescent world turns photons and particles into thin-air chemistry that glows in green and red. The pulsar spends spin into fields and pairs that probe and sometimes perturb both. Energy changes costume, spin to pointing, shock to chemistry, chemistry to stars, stars to metals, metals to dust, dust to molecules, molecules to clouds, clouds to clusters, while observations across bands transform into receipts, a microsecond of lateness in a tick, a kink in a tail, a ratio of lines on a limb, a polarized strand in radio and mid-IR. Give the plume carrier any name you like, cluster surfer, comet disk, wakelet nomad, the physics persists, pulse into weather, weather into birth, birth into memory, memory into matter, matter into worlds, worlds into new winds. Downstream of the plume-bearing pilgrim, shock after shock sets the chemistry pacing like a drummer with a variable metronome. First pass compressions ionize skins and strip volatiles from grains, second pass waves, weaker but broader, let recombination and molecule making catch up, so CO and H2_22 CO flare where just a few mere earlier only C2, and OI, could cool the gas. In the narrowest filaments the alphane speed climbs toward the sound speed and shear rolls lengthen. Eddies become more like braided ropes than whirlpools, and dense knots ride those ropes intact for tens of parsecs before another shock trims them thinner. Where the streamers kink around a pressure ridge in the cluster medium, a necklace of young clusters brightens in near UV like a string of buoys marking an underwater ridge, gravity, turbulence, and field tension briefly agreeing on a place to turn gas into stars. The lighthouse keeps adding needles to the map. When its beam clips a tail at low frequency, the pulse profile grows a scattering skirt that fattens and thins with the eddy turnover time measured in optical line widths, letting you close a loop from microseconds to kilometers per second. Rotation measure synthesis across many orbits peels the wake into depth slices, a thin drape of strong, orderly field at the nose, a tangled braid where mixing layers proliferate, then a calmer, low RM, low variance zone far downstream where turbulence has gone subalphenic and clumps can finally cool without being torn apart. Even the rare nulls, minutes when the pulsar's radio engine falls quiet, turn useful, revealing the baseline of background polarization without the lighthouse's glare, so the tomogram of the jelly's magnetism is solved with and without the probe switched on. The crescent world's limb hosts its own cycle of rise and release. On quiet nights the green line thins to a sharp razor at 95 km as O1 to the power of 11s, loses its race to collisions. After particle rain the red 630.0 nanometers doublet swells higher, a lantern at 250 km fed by recombining O1 to the power of 11d. Gravity waves propagated up from weather below carve the airglow into rippling chevrons, their phase speeds readable like isobars for a sky made of molecules. Sodium blooms in a lemon-pale ring after a meteoroid stream and drapes downwind like a scarf, potassium lags by hours to days, and their phase offset fingerprints the competing clocks of photoionization and ballistic lofting. When the star flares, nitric oxide spikes and bleeds the heat away in infrared, the F layer lifts like a sail, and the pulsar's dispersion measure through the limb nudges upward by a hair before settling. Space weather logged as chemistry, chemistry logged as time delay. Back at the head of the streamer-haired wanderer, torques decide the fate of the core. A mild bar or lopsided spiral can smuggle leftover gas inward even as ram pressure shaves the outskirts. The black hole answers with a short radioloud cough, inflating X-ray cavities whose bright rims sparkle in O2 and N2. That same outburst exports relativistic particles into the plume, flattening the low-frequency spectrum and raising non-thermal pressure just enough to stiffen cold knots against evaporation, a paradox where quenching at the face sustains birth in the hair. If torques fail, strangulation rules, star formation ebbs from the center outward, the disk drifts toward an S0 remnant, and the wake fades from H-alpha to far to only radio as massive stars die and dust cools to silence, leaving behind bound clusters that graduate into intracluster citizens. The hot bath is no mere backdrop but a weather system with its own calendar. Sloshing from an old subcluster merger sends gentle, kiloparsec-wide internal waves through the ICM. When the plume bearer crosses a crest, ram pressure ticks up, the tail narrows, and shock tracers, S2/H-alpha, OI, briefly rise. Cold fronts, contact discontinuities with sharp entropy jumps, tilt the headwind vector and emboss an S-curve into the gaseous hair. Magnetic draping layers thicken when the ambient field happens to align with the galaxy's motion and thin when it does not, toggling cross-field conduction and, with it, the field length that decides whether a cold core evaporates or endures. Stack polarization from dust alignment in the mid-IR atop radio Faraday tomograms and the 3D geometry resolves, plane of sky angles from grains, line of sight field from electrons, kinematics from H-alpha and CO, depth by triangulation rather than guesswork. Inside the filaments, enrichment proceeds in chords rather than a single note. OB winds lace the gas with alpha/alpha elements early. Type Ia supernovae add iron on centimeter scales, dust, shattered in shock skins, regrows by accretion in the shaded interiors where UV softens and collisions are kind. PAHs, fragile in hard fields, flare again as the radiation spectrum reddens. CI, lines bridge atomic to molecular zones just where CO ladders steepen, CO and CH3_33OH spike and then relax as grain fragments restick. Meanwhile, escape fractions for ionizing photons run higher than in settled disks because turbulence has already punched low column channels, so tail H2 regions leak into intracluster night and, halo by halo, harden the radiation field between galaxies. Even the statistics of newborn stars carry environment's watermark. Pressures in the densest knots rival starburst nuclei, nudging cluster formation efficiencies upward and seeding bound systems of 10510-5105, 106M10-6/M_/OD at 106M. The best bound survive gas expulsion to become ultra-compact dwarfs, their internal, alpha/Fe, \alpha/\mathrm Fe, alpha/Fe, patterns, half-light radii, and velocity dispersions will, gigayears hence, still retell which radial zone of the Ramshorn disk birthed them. A few of the largest associations drag enough gas to flirt with tidal dwarf status, dark matter poor but star-rich islands that, if they endure, will orbit the cluster as mementos of a single plunge. And always the city-sized dynamo keeps the clock. Spin-down power feeds a bow shock whose standoff distance measures ambient pressure in situ. TeV photons close the energy budget by inverse Compton on the microwave background. Breaking index detours and exponential glitch recoveries whisper about superfluid vortices pinning and unpinning in a crust denser than nuclei. In rare alignments, the beam, the crescent's limb, and a bright streamer share the same sight line. Then the pulse acquires a dispersive step from the planet, a scattering tail from the filament, and a polarization twist from the wake, all separable by their frequency laws, turning a single tick into a three-layer biopsy of a sky that spans 20 kilometers to 100 kiloparsecs. What looks like a collage, lighthouse, razor-thin air, comet-tailed exile, keeps resolving into a circuit where conversions never stop. Spin becomes fields and pairs become shocks and waves rewrite chemistry, chemistry cools gas into stars, stars forge metals and dust midwifes molecules gather into clouds collapse into clusters escape to the cluster night and pay forward their light. Read it in the green whisper at a limb, the UV knots beating a streamer, the microsecond hesitation of a radio tick, and you have not a still image but a choreography, an economy of energy and elements conducting itself across scales, each act leaving receipts in photons and time.